Okay, here's a simple rotational equilibrium problem, which was on the 2011 exam. This particular diagram and solution is by Colin Hopkins. So the question asked, what is the normal reaction from this point B on the board if you have a diving board here of mass 80 kilograms and a diver on the end of the board of mass 100 kilograms. Now this is a really good diagram of this type of question because it very clearly shows all the forces which are acting perpendicular to the beam. So when you see a question like this, drawing a diagram like this is one of the first things that you should do to make it really clear where all the forces are. And what you want to remember is, and probably write down in your solution, is that you know that if the diving board is static or still, the sum of all forces must be 0. And the second condition is that the sum of all rotational forces or torque must be 0. That is, the anti-clockwise torque must equal the clockwise torque. So to solve this problem, first of all, you have to take a point around which you can take your moments or sum all your torques, and you can choose that at any point along the beam. And the trick is to choose a point which is going to give you the most helpful information. In this case, you know the force that's acting here because you're given the weight of the beam. You know the force that's acting here because you are given the mass of the diver and therefore the weight force that he is going to exert. So the only sensible place to sum the moments here is around point A, because by summing the moments around point A, you can get two known forces and the unknown force here, and you're given all the distances from those forces. So you can successfully sum the moments anti-clockwise and clockwise. So as Colin's done down here, you simply do the equation, and you can write this equation down: the sum of all the moments clockwise, or the torque clockwise, must equal the torque anti-clockwise. Okay, so in this case, he's written this equation here. The force FB, which is the force you're looking for, the normal reaction from this point, times the distance from point A, which is 1 meter, is equal to the sum of the torque in the opposite direction. That is, the weight force of the beam times 2 meters, which is the distance to point A, plus the weight force of the diver times 4 meters, which is how far the diver is away from point A. And of course, to get those forces, you have to multiply the mass by gravity in each case. And then, to get the torques, you multiply by the distance from point A. That gives you a simple equation where the only unknown is this particular force here. And the result in this case is that FB, which is the reaction force from this point B, equals 5.6 by 10 to the 3 newtons, or 5,600 newtons, which was one of your answers, C. So you can circle C and you get full marks for that question.